And welcome to our penultimate video for this wells hydraulics course. And these last two videos are going to be about MODFLOW and how we can model wells in MODFLOW. So I haven't really introduced MODFLOW yet. So this first video is about MODFLOW in general and what it is. And then in the next video, in the next short video, I'll just show a quick example of well in MODFLOW. Okay, so really what MODFLOW is the general finite difference model from the USGS. And for those of you outside the US, the USGS is the United States Geological Survey. This is a federal agency here in the US that is responsible for everything geological, and so hydrology falls into that category. So a lot of water research is done by the USGS for the federal government. And so with that mission, essentially, they have codes and scientific codes that are available to the public, and so MODFLOW is really the groundwater flow code, right? Again, this is completely free, meaning it's available to the public. You can download it. You can look through the functions. You can use the code. It's completely available. What it does is solve the flow equation. So again, you should recognize those equations by now from this class. But you can see that you can have heterogeneous formations, right, with different hydraulic conductivities in X, Y, and Z. You can have wetting, or you can have source and sinks, basically, and of course you can have unsteady heads. So again, these equations by now should be you should be very familiar with them, and all it's doing is exactly what we've been doing with our little Excel, basically finite difference code, except now it's a 3D code, of course. It has all the unsteadiness, all the tricks basically in the books. Now, MODFLOW also has solid transport and particle tracking modules, and again, I'm not going to talk too much about it here, but this is sort of foreseeing the third course here on contamination, where solid transport is all what we talk about in that third contamination course, and then particle tracking is really useful to visualize where solutes are going, essentially. So there's many more modules. I just want to mention those kind of solute transport related modules here. Here's the well here. A well package, for example, right? That's included in MODFLOW 96. You can see in which version. So that's what we'll see an example of in the next short lecture. But you can see there's a ton of different packages. There's some statistical analysis packages, for example. There's anything you could think of, essentially. You can see here evapotranspiration package. There's a lake package, so on and so forth, right? A reservoir. Many a stream package, so many packages that allow you to do a lot of different things, essentially. So of course it's very popular because it's available, publicly available, so anybody can go grab it, read the how-to files, essentially, and use MODFLOW for groundwater. There's a lot of private sector preprocessor and post-processors, and I talk about some of those, but here are a couple examples. Visual MODFLOW is famous, and then GMS, I'll do an example with GMS, which is groundwater modeling software, it's called, and I explain, I'll talk about this a little bit more after that. So the problem with MODFLOW in general is that it's not very simple or practical, and so it's usually better to use one of those pre and post-processing packages. The reason it's not practical is because, again, MODFLOW is coded in Fortran, and it's one of those, old-fashioned, I guess, scientific codes where you have the wrapper or the input files are all text files, right? So it's very specific and particular about how you need to input, data, like your domain and, the hydraulic conductivity, etc., etc. So it's many text files that you have to edit, and it takes a bit of getting used to, I guess, to really get up to speed and be able to really use MODFLOW in its standard original form, right? So a lot of companies have developed those user interfaces that sort of hide all the code behind a more user-friendly, more usual user interface, and then you get menus and you can click on buttons, and it's just more intuitive and user-friendly, obviously, to have a user interface to interact with the code. So here's an example, the visual MODFLOW from Waterloo Hydrogeologic. So this is another, okay, so freeware, there's a few free options out there, basically, that provide you with a user interface. You can see them here and here. These are user interfaces, processing MODFLOW. Model Muse is a somewhat famous one, again, because the USGS put it out. The problem of those free ones are they're not very good, essentially, right? They're pretty limited in what they can do, and compared to the commercial ones, they're typically not that good. One that I personally kind of like is Mflab, which is a MATLAB package. MATLAB package, basically, that you can, again, that's free, and that allows you to use MATLAB to interact with MODFLOW. So that's a good option if you know MATLAB. But again, of course, if you don't know MATLAB, then you're back to the problem of having a bunch of scripts and text files to interact with the actual Fortran code. So there's little choice. Either we do it the hard way, so we learn to edit all the text files by hand, and all the inputs needed for the model, or we buy an expensive user interface and learn to use it, or we can use a free user interface and learn to use it, right? There's no kind of shortcuts. All those options have, positives and negatives, I guess. So again, another couple of examples. This one, EVS software. I'm not going to talk more, but you can see how, neat, I guess, those post-processing codes are, because you can really visualize things, and it's kind of nice. And the one we'll use here is groundwater modeling software. So this code specifically is from a company called Aquavio, and there's a bit of a story behind it, because Aquavio apparently was founded by people from the Corps of Engineers. So again, for those of you not here in the US, the Corps of Engineers is affiliated with the Army, essentially, so it's the Army Corps of Engineers, and they are responsible for anything waterways, essentially. So if you need, any sort of construction or water usage or, hydraulics work on a waterway, the Corps would have authority to issue permits, to, design, etc., etc. So the Corps is really important here in the US. And apparently this company, Aquavio, was originally spun out of engineers at the Corps, again, to use so the Corps of Engineers has some surface water models. The HEC-RAS models is from the Corps, essentially. And so they have, they wanted to have some more user-friendly interface, and that was the kind of how this company got started. And the Corps doesn't really have the groundwater model, but the USGS does. So Aquavio sort of did a module that is groundwater modeling as opposed to surface water modeling, which they also do, at Aquavio, but more based on HEC-RAS, essentially. Okay, so I think this is the overall general overview of what MODFLOW is, how we model groundwater. And again, pretty much anything that you'll see out there, in the real world, doing some groundwater modeling will use some sort of MODFLOW, either MODFLOW directly or, codes that do the same thing as MODFLOW, which is what we did in this class, right, when you do your own sort of codes, right? So some companies will have, in-house codes where they do the final difference themselves for some specific projects, but typically you just use MODFLOW or some user interface that has MODFLOW in the background. So again, in the next and last short video, I'll show you an example of a well in GMS, in that groundwater modeling software from Aquavio, using MODFLOW in the background. Thank you.